So I'm going to explain property-based testing in general and show how things are done in ScalaCheck and what is coming in ScalaTest. And it's not actually finished, the stuff we're doing in ScalaTest. So I would like to get your feedback. If there's some way that we were thinking about doing it that you don't like or you think could be better, I'd love to hear about it. And so maybe you can actually influence the design a little bit. But just to give you kind of some basis on why I think it's important, I wanted to start with this page of code. Does anybody know what language that is? Not Scala. Well, see, that's what happened. Eiffel didn't make it in the marketplace. This is Eiffel code. It was done by a guy named Bertrand Meyer. And this was kind of a competitor to C++ and C++1 out in those days. And one of the ideas he had in Eiffel is called design by contract. He trademarked design by contract, TM. And in Eiffel, you actually had to specify a function when you wrote the function. So there's these three parts to a function body. This is the square root function. Real is like double, right? And you have to say require, and then you put some assertions that are called preconditions. Then there's do, which is actually the body, because back in those days you're actually usually doing side effects, so it is do, kind of makes sense. And then there's ensure. Is it ensure? Ensure, where you put what assertions he called postconditions. So preconditions, the contract was preconditions are the responsibility of the caller, and postconditions are the responsibility of the provider of the service, the person who writes the function. So the deal is, if you give me good input, I'll give you a good output, right? That's the contract, essentially. But it was a way to specify what do is doing, right? So what he says here in this case, this is a square root function that'll take any real number. And if it's 0 or greater, or positive, or 0, then it's going to somehow compute the square root. I left that at dot, dot, dot. That's just an exercise for you guys later if you want to do that in Eiffel. Then the way the postcondition works is he takes the result that the sort of candidate result to return, which is the square root of x, square it, and in the ideal world, you'd get x back, right? But this is not the ideal world. It's real or double, right? So there may be a little rounding error. So what he does is he takes the absolute value. Well, he subtracts x, actually. That gives, in the ideal world, 0. So then he makes that little difference, possible difference, positive by taking the absolute value, and then he lets it be, makes sure it's less than a tolerance that he's willing to admit. So Scala actually has two things in it that support this style, this design by contract style. Assume, how many people knew Scala had an assume in predef? 1. So nobody knows it. It is in the Scala book, the Stairway book, in a footnote in really tiny print. It's there. It does the exact same thing as assert, but it's intended for preconditions. So it's, what it does is it throws assertion error, like on the JVM. That's what it throws. Then there's something called ensuring, and so this is like I've written a square root, all spelled out method here, and my assume just says it has to be greater than or equal to 0, and it's not positive infinity. And then I call math.square root. What math.square root does is if it's a negative number, it gives you back not a number. So what my function is going to do differently is it'll throw an exception if it's a negative number instead of giving back not a number. So what my ensuring clause does is the same thing the Eiffel code did. It squares the results. So when you call, like the candidate result is returned by math.square root x. So on that I invoke ensuring, and I pass to ensuring a function into which that result is passed. And then I compute my tolerance. I square my candidate result, subtract x. In the ideal world, that's 0, right? Compute the absolute value, make sure it's positive, and I compare it against the tolerance. So it's the same thing. So essentially, people don't mostly do this. This didn't win in the marketplace of ideas. What won in the marketplace of ideas was JUnit, right? You take the post conditions and you put them in this other place. So you put it, mix it in with your body, your main code. You put it in this other place called a test. So the precondition, though, yes, Azad.
Is that part of the standard library?
It's in predef. You can call it on anything. So I'll show you a demo of it. It's very simple. Let's say console here. This is SBT. Let me make that a little bigger. See what that looks like. That's too small. Test colon console. I'll just show you test. All right, test colon console. So basically, I decided since this isn't all finished, that the talk should mostly be demos. So it's mostly demos, but if I just say 42, just as a random number, ensuring, and then what you do is you have a method coming, like you pass to it a function that will, into which 42 will be passed, and you can say I greater than 0, that will be true. It just returns 42, so that gets returned. But if you say less than 0, then it throws assertion error, so it's an assertion. And nobody uses it. Very, very rarely do I find people using that. Not very many people even know it's there. What we use is this. We use require, which was the JVM way. I mean, actually, one of the things that Eiffel did was it made very fine-grained ways to turn on and off assertions. So the idea was, if I go back to the Eiffel code here, I write all this, but I don't necessarily want to run that all the time. So it may be slow, especially in those days. This is 20 years ago or whatever. So by default, what is enabled is just the require clauses. Those are run by default, and then the default is the ensuring clauses are not run. So you would like enable them for development and testing, and then you turn them off or even whatever you want to turn off. So what the Java people settled on is we're going to have these require precondition checks baked in, but we don't throw assertion error because assertion error can be turned off on the JVM, right? We throw something that can't be turned off, illegal argument exception, or illegal state exception or null point exception. Those are the ones that we threw, right? So we did this, and we took the post condition and we stuck it in a test. So this test is written in terms of a property-based test that says for all doubles, whenever the precondition is met, then the post condition should be met. And so I have to add that to move it to a test. I actually have to add that for all, because if you go back and look at I'll look at the Scala code here. Basically, that assume and this ensuring, they're going to be called on any x that can be passed in, right? They have to be true for any kind of x that can be passed in, so all x's essentially. So that's what you can say in ScalaTest. Currently with ScalaCheck behind the scenes running the property check. And it's called a property. The property is that the result after you square it should be equal to the original within a tolerance, right? That's the property that function should behave or should exhibit. Okay. So anyway, that means we actually repeat the precondition twice. We say it once in the test and we say it once in the production code. It's kind of duplicate. But the reason I thought this was important is because I think I have this one talk I gave a couple times called the essence of testing. And I said that the essence of testing is this kind of logical formula which says for all x, px implies qx. So it's kind of what happens if you take design by contract, which has these things inside the body, and you move it out to somewhere else. You end up with a statement of logic, a logical statement, which specifies the function that you're testing. So in our case, when I said for all x colon double, that's the upside down ax, and then p is the precondition, happens to be called p. That is that it has to be greater than or equal to 0, and it's not infinite, right? And then q, f is like the function under test, so that's like, in our case, square root spelled out. X is still x, but then you pass in f of x, you get the answer. So basically I make an assertion using the function f and the original thing x. So that's, I think, kind of important. It's really fundamental to testing. It's not this kind of thing off to the side that Haskell people did. So I think it's important to ScalaTest to have really good support for this. And one of the things that we are doing with ScalaTest in general is migrating our third-party integrations to modules, because ScalaTest is really too big. And so one way to make it smaller is just rename things and move them to separate modules. So if you just ask for ScalaTest, you don't get the JUnit, the TestNG, the Selenium, if you're not using that, the Scala mock, the Mockito, the JMock, all those things are kind of all bundled together. And then also ScalaCheck. So we're just moving it out to a separate module. So we'll just rename the packages, but it'll work the same. But one of the reasons that we want to do that for ScalaCheck in particular is because of when a new version of Scala comes out, ScalaTest has got is one of the first, it's like really in front of a lot of things to be able to be built because a lot of people use it in their project. So we use ScalaCheck and Scala XML. That's the only two things we use. So we have to wait for ScalaCheck to be built before we can build ScalaTest for a new version of Scala, like Scala milestone releases and whatnot. So back in M5, that actually took like 6 weeks before ScalaCheck was working for that one. And then after we got it, in a day we had, and that was not even working yet for Scala.js, just JVM. So then within a day we were able to build it. So we'd like to just, once it's a module, a separate module, then we can just build it right away. And then when it comes along, it comes along. But there were a lot of other things also that I thought could be done differently. So I want to show you, this is what I'm going to go over during my talk. And I'm going to mostly show demos. And after each demo, I'll take a few questions. Not a whole bunch, but I'll limit it. But just so you can, if you have questions, you can ask as you go. And remind me to repeat the question if I forget. So the first one is, generators are available directly in arbitrary. This is a little minor thing, but it'll kind of get my demo started. Import org.ScalaCheck. So for some reason, Ricard and Nielsen, the fellow who did ScalaCheck, wrapped he didn't want the generator to be the implicitly available thing. To grab it, you need to say, let's say ScalaCheck arb, int arb, let's make it an int arb, equals implicitly arbitrary of int. So you grab an arbitrary implicitly, and I got one from ScalaCheck. So then I can say the generator is just called the arb.arbitrary. All right, and now I got a generator. Oops, I forgot to say val. Okay, now I got a generator. So now I can, with that guy, I can say sample, and you can see some ints. This is an int generator. Okay. So, it's minor difference, but for Scala tests generator, what you say is just st int gen equals implicitly generator of int. And you just get one. Okay. So then you can get samples out of them, for example. So you can see that basically they generate ints. And let's see what. Okay, so another thing that you may have noticed is that basically when you ask a Scala test generator for an int, you get an int. But if you ask ScalaCheck, you get an option of an int. So that was another thing that basically I thought would be better if a generator of t just gave you t's, served you t, rather than maybe t. So the reason that it does that is just so that he can do things like this. There's something called such that. So if I take my ScalaCheck int generator and I say such that, I can say given a generated I, let's only, how do I do that? Let's only, now I don't remember what such that takes. Let's only, oh, it's Boolean, that's what it takes. So let's only do positive numbers, or 1 and greater. And now I've got a new one. Let's name it something val pos int gen. I'll call it ScalaCheck's pos int gen, like that. So that's a nice one-liner. And then when I use that guy and get samples, I get some nones. Anything that would have been negative or 0 comes out none, right? So. So in ScalaTest and in ScalaCheck, you could also do this. You normally compose new generators of old ones with a for expression. So I'll make one called ScalaCheck pos int gen. Sorry, I did that already. ScalaTest pos int gen, like this. And I'll just say for, and you say for an integer in the generator, ScalaTest int gen. So that was the one I grabbed implicitly, right? I have a generator of ints. I'm going to take an int out of that, and then I'm just going to say j is equal to, what I want to do, if it's greater than 0, that's cool. I'll just return it. Else, I want to do something else. I could just return 42, or I could take the absolute value of it, right? I'll say i.abs. And then you just say yield j And now I've got this is a generator of int that will only generate positive numbers with no sums or nones. It's just always, it just gives you back another positive number. So can anybody see a bug in my slide? Is there, I mean, assuming that I'm promising you I'll give you a positive number. Is there any way this could give a non-positive number? No, I equals 0 will get, oh yeah, it'll give 0, you're right, that's one. Okay, there's a bug I didn't know about.
For the min value, right?
Yes, what happens with min value.abs?
Yeah, there's no corresponding.
Yeah, so int.min value is 1 bigger than int.max value. That's what the problem is. And that's kind of good to know. See, there's an 8 and a 7. So when you take int.min value.abs, you get back int.min value. So that's another way I can, there's 2 bugs in this one. So I'm going to say stpos.int.gen dot sample. Anybody want to place any money? I'll get either 0 or minint. No, good, smart, because it's like 2 to the 32 to get either one of those, because we tried to, let's see if we get it. Oh, it'll be a while. Okay, I'll just give up on that. So, but there is a bug in that one. But that's basically what you're forced to do. You just have to, like, if you want to get rid of something, you have to replace it with something else, and you've got an int.gen, right? Okay, so that's one slight difference. And then another one is repeatability. This is something that since we started our work, which we did a couple years ago, it got fixed in ScalaCheck. So they actually broke some code in ScalaCheck to add this. So I'm going to actually run this flaky test spec. So kind of on the same, well, can anybody tell me why this test would be flaky? So this says for all, let me make it a little bigger. For all ints, x plus 1 should be greater than x. Plus is a, I'm testing plus on int now. Just make sure it works. Can anybody, Max int, right? Because it overflows, so that'll be negative. So hopefully when I run this thing, let me say :q, and I'll say test only star flaky test spec. I should get some failures and some, that's a success, that's a failure, that's a success, that's a success, that's a failure. So it comes out fairly often. The reason is we try edge cases, and max value is an edge case. But it's hard to reproduce, so what the feature that people wanted was that I could actually reproduce one of these failures exactly. So we print out the seed. Essentially what ScalaCheck originally did was they used Java's random number generator, which is just mutable. So what you have to do to be able to make it reproducible is have a functional random number generator that is it's a immutable object, and it'll generate the next int and give you back at the next random number generator that you feed through, right? So if you just give that the same seed, then I can reproduce that error the same every time. So then to go fix it, one way we could fix it is I could stick a whenever in here. Whenever x is not equal to int.max value, and then I'll say this assertion. So I did not specify the whole behavior because it might be, it's probably better to say if it's int.max value, then the answer is whatever it is, min value. Otherwise, it's this thing. But just to show you this, so now because I'm running with the exact same data, I should know that I fixed it, right? So I want to just show you again this, this shape. I've got for all ints, x is int now. The precondition, the p, is x is not equal to max value, right? And the postcondition is when you add 1, you call the plus method and pass in 1, the result should be greater than the original. That's my q. And f in this case, the function I'm calling them testing is plus. So, okay. Okay, so that's a demo. Anybody have, oh yes, you have a question. Perfect timing, yes.
Yeah, so you said, this thing you said about seeds.
Yep.
How does that work with parallel tests? Running your tests in parallel?
I feel like that, I just reminded of the Monty Python where they ask him about the swallow and he gets ejected. I don't know. That's a good question. So what I can say is that each for all gets the seed. So when you start up ScalaTest, you either specify a seed and it gets stuck in a variable that's like global. It's in the randomizer companion object. And a randomizer is the immutable random number generator. If you don't do that, then there's one that's, the first time it's used, it just snaps to something grabbed from the time of, right? So, but it's each, like if you have 10 different tests with 10 different for alls, they each get that number they start with it. So each test starts with that. Each for all starts with that. Yeah, so that means every for all is using the same seed, but that's okay because next time it'll be a different seed. And it doesn't matter, really. So if you have parallel, what in ScalaTest normally happens is suites run in parallel, but within a suite, the default is the tests are not running in parallel. You have to mix in parallel test execution, but then each test is a sequential thing. So I think basically everybody's going to be using that same initial seed. It would be the same seed. It should work. So any other questions? I'll take 2 each time. Okay. Okay, so let's see here. Go back to my slide. So that's randomizer and flaky test spec. And just to show you randomizer in the Scala doc here, see how that's really tiny. Make it bigger. It's in the prop, or will be in 3.1 in the prop package randomizer. And it's an immutable class. It's a functional object that has a bunch of methods. Here's choosing things between a min and a max. And then there's just a bunch of next methods, of different kinds of types. But you don't just get that back, you also get the next randomizer, because this thing's immutable. So for it to be different next time, you need to use the next one, the next randomizer. So you can see that right in these outputs. They're always outputs a tuple with an int in a randomizer or a double in a randomizer. So that's how that works. And I think ScalaCheck has that now too. So what is going on, the way these are implemented is with implicits. You saw me looking up implicits. So the way the for all works is you pass a function to it. It has a type for its input parameter or parameters. Right here I just have one parameter type int. So there's this hidden implicit parameter being passed at the end, and it's going to, Scala compiler is going to look up for an implicit int generator like I just did by hand. It's called ints, so it fills it in there. That's where it comes from. So that's how for all knows how to get that values of that type. And that's kind of like one of the big ideas of property-based testing is you don't have to think about like, oh, do I try this one, I try this one, I try this one. When you choose them by hand, it's just you have to think about, well, how do I get a generator for the type I'm testing? And then let it generate them. And you hopefully will cover more bases. So if it's double, like this one, then there was a little doubles. It's called doubles. And that's an implicit generator of double that's just grabbed and used by the for all. So that's how that works. And so just to show you that, I'll go back to test:/console. And I can just say int. So it's called int. That's a generator of int. And I can say samples 100, so you can just see some of them, or double samples 100. Basically, generators generate. Whoops. I can spell doubles. Okay, and so one difference with ScalaCheck is that like our samples, you see they're evenly distributed, where ScalaCheck will mix in edge conditions into the samples. But that's basically just that's what these things do. They generate data of some type. And so for lots of types that you might use, there's just off-the-shelf generators, but that you need to be able to make your own. So what you usually do with that is a for expression, like I showed before. So another way to do this thing would be, instead of adding a whenever clause, is to use a generator that doesn't produce, what was it, max int? Max value, int.max value. So let's actually change this back to one that fails, make it fail again. We'll go back to this guy. Whoops. Well, definitely that one I know will fail. So I got this to fail again because I'm using that same seed. So what I can do to make a generator is I'll say val ints other than except for max value. I'll call it for the heck of it. And then I'll say for, and again, I'll take an I out of the regular one, which is ints. And then what I'll do is say j equals if j equals int.max value. Let's use 42, why not? Else I. Sorry, that's not going to work. That's recursive. If I, right? Is that right? Why is that red? Oh, because I haven't put a yield. Yield j. So I actually need to. So I can make this implicit, and it should actually that should heal it, because now this one's going to overpower. It's going to find this one in scope instead of this is. Well, let's have IntelliJ tell us what it is. I can actually wait for the light bulb and say add type annotation. It is a generator event, right? So we just made a generator event because we started with a generator event, and we yielded an int. So it's going to find that one. This should actually heal it. Go here. OK, so that did. Just want to show a few things, and you can do this with ScalaCheck as well. If you have a custom generator, instead of making it implicit, you can just pass it in explicitly, but not at the end. You can just say for all ints except max value. I'm going to get rid of that 4. I said 4 and I typed it. OK, so I can do that. And that's another way to do it. That should work. You can just pass it in there. So you can say for all ints except max value to make it more obvious. I think it's more obvious. You can also pass in, if you notice here, the name of the parameter is x. Oh, I got to get to fail again. Let's get it to fail by getting rid of this. So when it fails, it just gives you the value that was passed in here. You can actually, if you want, put the name of the parameter here, like this. It's called, you call it Fred or whatever, and then that'll get reported in the error message. It said that the x parameter, and that helps when there's like 5 parameters, but they're in order. And then if you want, you can combine these things and put them together. And I think I need 2 parentheses here because that's a tuple. Oh, what? Thank you, IntelliJ. OK, and now how do I make it? Oh, I made it pass because I put the generator that doesn't generate max int back in. So those are some things you can do. All those things with ScalaCheck integration with ScalaTest as well. But that's kind of the idea: is you make new generators out of old ones.
So this
Yes.
is the new ScalaTest.
This will be ScalaTest 3.1, and we're close. We have a first pass of all the documentation finished, so we need to edit that and maybe a few more passes. We don't have a few pieces that I noticed actually preparing this talk. Oops, that's not there yet, so I have to write that. But it's not that far off. Yes?
What about your own generator for support of case classes or user-defined case classes?
Yeah, so for case classes, what you could do, there is a shorthand for it, but let me show you the what you could do is, let's say case class person name colon string age colon int. Now there's, this will allow negative ages and empty names and that sort of thing. So you might want to, but we'll pretend like that's fine for now. So I'll say person gen. To make a person gen, I would say for take the age out of the ints. We have pos ints too, but well, let's do that. Why not? Pos int values. It could be 0, so pos z int value. So basically, there's these off the shelf. That's an A. Posey is named after Buster Posey. Since I'm in San Francisco, I figured somebody would know who that is. Name in. Oh, I usually put name first, but it doesn't matter. So name, let's say, well, I'll just make it out of strings. It's going to have a Chinese name most likely, because there's a lot more of those than there are letters. We could say alphanumeric strings or alpha strings or whatever, but I'll say yield person name comma age. So now I can say person gen dot samples. Let's say 20 dot for each print line. You'll just see them lined up. See what they're they look like. Whoops. Okay, we have some, yeah, I told you it's mostly the Chinese are taking over. And look at how old this Chinese, that has got to be a wise old Chinese person. They're like, yeah. So it's this thing. Normally you make a 4 like this, and you just take some generators and you yield a new one. So it's a monad. So any other questions about that so far?
So did I see, did you test with an empty string?
I did not.
So the samples seem to be, I mean, they seem to be randomly distributed, but the ScalaCheck generators, I remember they put some emphasis on the
They
edge
do.
cases, which is actually very helpful.
That's correct. Yes. That's one of my, it might be my next one. Let me see if that's my next topic. Yes.
Yeah, okay.
This is a
Yeah, okay.
very good,
Thank you. Thank you.
a very good segue. So what he said was that ScalaCheck puts some emphasis on edge cases.
Yeah.
So I said favors, but puts emphasis is a good one. So let me, let's see, let me grab, we have an SC. So let's try this guy. So what you can do in ScalaCheck, they don't have like a way to get 100 samples. You just got to collect them. So I don't have, we called the int generator SC intgen. Okay, it may not be in scope anymore because I closed it. Okay, I'll have to make it again. So implicitly, actually I have the code right here. I'll just use this one. Copy and paste. So there's my import. This is stuff we did before. I got an arbitrary. I just called it arb this time. Got a gen. I called it gen. Okay, this time. And then now, if I say gen.sample, there's my thing. And you can see, you'll see right there, there's an edge case. See coming out?
Mhm.
There's another one. So let's get 1,000 of them. And what I'm going to do with this, so 1,000 list.fill will fill a list to 1,000 elements when I say 1,000. The second thing is the function it calls for each element. So it's going to call that function 1,000 times. It's going to get 1,000 samples. And because I have faith in ScalaCheck's int generator, I believe it will always be a sum. I think it is. But it's basically faith. So I say .get, right? And that's how I get the actual a list of a bunch of ints. So what I'm going to do with those is try to count them. So the first thing I'll do is I'll group them. So this guy says take that 1,000 ints and group it by the int itself. So now you'll see, for example, that this number appeared once in the list because it's associated with a list of itself one time. But this 0 here appears many times in the list. It's associated with a list of all the times it appeared in the 1,000 ints, right? Because they favor edge cases. So then what I'm going to try to do is just get rid of the ones that I'm going to filter out, exclude the ones that have a length of 1. So filter means keep, like retain the ones that pass this function. So the ones that don't have 1 get to stay. So I see 2 edge cases here, zeros and minint, right? And then what I'll do is, if I say keys, that's going to give me the edge cases. I spelled it wrong, filtered. There we go, that's them. So that's the same edge cases we use. It's minint, max, int, 0, -1, +1. -1 and +1 are just kind of throw it in for good measure. But so there's 5 of them. That makes sense. So let's get the length. So what I'm doing in this one is I'm taking the one that just has these 5 key value pairs, and I'm changing the value instead of a list of a whole bunch of things. It's just the length of that list because I want to know how many it made. So now if I take that and print it, you'll see about how many they generated. So 92, 111, 93, 96, 96. So I think the heuristic is about half of them are edge cases. So if I compute the sum, lengths.values.sum, it should be around 500. Okay, 488. Sometimes it's above 500, sometimes below. Essentially, there's only 5 edge cases. I tried them 488 times. That's actually 483 times I've tried the same thing over, and it's going to do the same thing, right? So that was what I didn't like. Now, if you compose 2 ints generators together and have a tuple 2 with 2 ints, now there's not as many duplications, right? But I want to try to improve on that, and because it's greenhouse gases, right? Bitcoin mining and this is like it's heating up the planet. So what? Yeah, it's just you think you're testing a lot, but you might not be testing as much as you think you are. So what we do is different, and what I thought I'd try is first we try edges, and some of them, some number, and I try 20% at most, or until we run out. And then we just try evenly distributed values. That's what we do. And the other difference, well, actually, no, that's not a difference. Never mind. So let's try that. So one thing you can do, for example, this is now, again, back to ScalaTest, you can see, I can ask the ints generator give me up to 20 edges, and you see the same 5 are there. It's the first list there. And then it gives me back a randomizer. So I'm passing in a randomizer. So they can, each time I get edges, it'll put them in some random order for the heck of it, because I don't always necessarily do all of them. That's actually a list. So doubles, again, this one is got a few more. There's negative infinity, -1, this -1 dot blah, 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 blah. That's the smallest non-zero. Let's see, what is that?
Yeah.
Oh, why is that before -1.0? I should put these in the other order. Wait a minute, no, that's the smallest, that's the closest to infinity, -1, that's it. Then -1.0. This is close to 0, -1. Then there's a -0 in doubles. Then a 0. That's right, see, that's the whole point. Like one of the services that property-based testing tries to provide is make you try cases you wouldn't think of, right?
Where did these edge cases come from?
They're in the doubles generator. So doubles is a.
So somebody actually put them in there?
I did, yeah.
Okay.
And there's one of the things I wanted to ask you about is one thing. So everything that I've said so far is also true on the positive side. But there's one thing missing that might be an edge case. Can anybody think of?
Yeah.
Yes, Nan. Yes.
Oh, no, okay.
Not a number.
I have another one. I mean,
Yes.
sometimes, what is it? 1.1 doesn't have a precise binary representation.
Oh yeah, that's good. What about pi? But anyway, I could go crazy. But not a number is one that I think we tend to not think about. But it's overflow. Same thing as like adding 1 to maxent. So I think it should be in here. Does that? What do you think?
But they're different.
Yes. Okay. I have one. We can vote. It is democracy. 1, 2. I have a couple thumbs up. You have to vote with your thumb. Okay. People like that. Okay. That's right. And there's a way to exclude it. Finite floats. Instead of saying for all floats, you say for all finite floats. So I think float, because it's float, it's like for all floats means not a number is a float. So, and that's kind of the point, is to make you think of that. But the thing is, not a number is a pain to work with because equals doesn't work on it. So you have to treat it specially. But anyway, did you have another comment?
So, I mean,
Grab my tea.
some numbers have a precise decimal
Oh, yes,
representation,
1.1.
but not a binary.
That's right. That's right.
1.1 binary.
I read that recently and I don't remember. But yeah, something simple like 1.1 doesn't actually,
At 1.1.
yeah. When you make it into binary, it goes forever and you have to, yeah, it's not precise. I mean, we can actually almost try it. But anyway, I think it's something simple like that at least. Okay, so what we do, if you look at,
Are you going to display the strings as well? What do you mean? How do you define evenly distributed when it comes to strings?
there's length, there's a size, same as ScalaCheck, that goes up and down, and then it just goes all over the Unicode area. But so just because there's more ideograms than there are letters, you see mostly Chinese things, and it seems like, which probably won't show up in your app, but it might find a bug that's useful to fix, right? So here, what I did is I printed out what gets generated. So the for all succeeds, but it prints what it got. So you can see there's 2 edges, and that's 20%. And it's different every time. And the other thing is, by default, and this is true for the ScalaCheck integration in ScalaTest 2, is a few years ago, we were running them 100 by default, because QuickCheck did 100 by default in Haskell. ScalaCheck did 100 by default in Scala. And I did 100 by default in ScalaTest because ScalaCheck did it, because Haskell did it. And what people do is they write this property-based test, and maybe it finds a bug. Most of the time it doesn't, but sometimes it might. And then you fix the bug, and then you run it for the next 10 years in condition integration, and it never fails. So why are we trying it 100 times every time? So I made the default 10, which you can just configure it to something else if you want more. But I just felt like, again, it's the greenhouse gas issue. I'm running tests that are never going to fail too much, because I'll just, within a day, we'll have tried all the edges, and, So,
Also gives a false sense of security if you think that you run it 100 times and it's not really.
Yeah. Yes.
Is it possible to increase that though?
Yeah.
Okay, cool.
Yeah, I think I just did, because I got a whole bunch more here. So one thing you can do, like hard code it, say give me at least 100 minimum successful. So I actually answered your question before you asked it.
That's perfect.
That's like property-based testing, man. So what this one looks like, so that's one thing I added, is you can add some config parameters right there, and then there's an implicit configuration you can just set everywhere and mix it into every test if you want like always 100 or 142 or whatever your number is. So what this one does is it takes two ints. So it's the same implicit int generator that I'm grabbing. Then I print out, the two values, and then I just succeed. So you can see them. So here, once you start combining them, now there's a lot more going on here. I get out of 100, I get 20 edges, and then the rest are random. So that's what we try to do differently. And then there is one way to, how do I get 100 out of the first one? This is, if I just do the first one, but I do it 100 times. So remember we were doing 20%, so it was 2. We run out of edges after 5, and then we just switch to this even distribution. So that's what, I try not to, I try to do the edges first, but if there's too many for 20%, I just grab random of those and do those, so that each time you run it in the continuous integration, you get different edges, 20%. But if you run out, then you just do the other guys. So that's edges. So that's different. Yeah, I think that's good. So then, so there's another thing called shrinking, which is really cosmetic. This is when you find, like, let's say there's a string that fails and it's 200 miles long and it's in Sanskrit. What it'll try to do is find a simpler string, or for some, to humans. It'll try to shrink it down to a smaller string or a simpler string. So it'll try alphanumeric character to see if that fails. And if they can find one within a reasonable amount of time, it'll use that instead in the test failure, because then it's easier to read. If it can't, it just gives you the original. That's all it is. So in ScalaCheck, that was separate, and this caused a rare bug, but it hit me once. There was this example I grabbed from Stack Overflow. So you can see that he's using Rickard is using a stream, still looks like. And the way it works is like let's say I find 10 as my failure. That actually doesn't work. Can you shrink 10? And this will just give me smaller, progressively smaller ones until you hit the end, which is called empty. That's a stream, a Scala stream, which I think was deprecated in Dotty. If 100 was the one that I found, then it'll give me progressively smaller ones, right? So it starts with what I found and goes smaller. Excuse me. So notice that in each of these cases, I have a 0 right before the empty, so it does go to 0, the shrinker. So if I were to make a new generator, I don't know if I have this. I'll grab it again. This is my trusty int generator from ScalaCheck. I'm going to grab this guy, and then I'll explain the code. This one is, what I want to do is make that non-zero int generator where I'm not passing in 0, like for the square root, maybe. Right? I want to make a function that generates all zeros, but I'm going to change the 0 to 1. I should have made it 42. But that's similar to the code I show you for ScalaTest generator. It's the same thing for ScalaCheck. There are monads. You can make a for expression, make a new one. But when I make my for all, and I'm going to do a for all that fails. Actually, wait a minute. I will, because I don't know how to actually pass it explicit. I'm going to make it implicit by putting it inside an arbitrary, right? Because the generator can't be implicit in ScalaCheck. It has to be inside an arbitrary, and then I will make a property. And this one is going to fail on, first of all, it divides I by I. That needs to equal 1. So that will work for anything except for 0, right? That will blow up if it's a 0. But my generator that it's going to pick up won't ever generate a 0. So that's cool. Then I just make sure that I is less than 1,000. That's going to fail as soon as is I is less than 1,000? Yeah, so anytime it's bigger than 1,000, it's going to fail, which is going to happen pretty fast. So when it fails, let's say it fails with like max int, then it's going to try to shrink max int. And the problem is the shrinker doesn't know I'm not supposed to generate zeros. So it throws in a 0 and it blows up during shrinking. That's the the sort of inherent flaw with the having them separate. So this is, when I check it, when I actually check the property, oh, this one didn't blow up, did it? Yeah, it did. There it is. Arithmetic divide by 0. So it did, when it tried to shrink it, it blew up. So what we tried to do in ScalaTest was put them together. So if I show the same kind of thing here, I just need to make my generator implicit. That's the ScalaTest one. Same generator, won't generate zeros. So I get a failure, but it doesn't blow up during shrinking, but it actually didn't shrink it. So I think that's better. So the shrinker is built into the generator now. So it's actually one thing. So when you compose new generators, you get a new shrinker. And usually I can't do too much with it. So what I do is I just pick a few pretty numbers. I call them canonicals. So for ints, you can actually ask the ints generator canonicals, and then I have to pass in a random number generator to get it to sort it. Oh, wait a second. That comes back as an iterator and a randomizer that I'm going to throw away. It.toList. Now you can see them. These are the canonicals. So that's actually all I'm going to use in my composed generator. Excuse me, is that guy. And that's good enough. I mean, it's just cosmetic. If one of those happens to hit, win the lotto, and it actually causes the test to fail also, then you'll get that as the output instead of the big number. But what's nice is that if you ask the compose one, where is it here? How do you say, give me your shrinks? I have to say val it comma underscore equals. Let me go to that. What's this guy? This one. So this guy doesn't generate zeros. It also won't generate zeros when the shrink. That's what it does. It gets rid of them. It actually turns it to a 1, which is redundant. I'll show you. I think I'll try to improve that. But that's shrink. And I say the number to shrink, which was this big number. We start with this one. And I have to pass in a random number generator. And I think I say it.toList. Now you'll see what was in the shrink list. It's everything that was in the canonicals, but I got rid of the 0. Right? So that's another thing that we're trying to do different is when you compose your generator, you could get everything. You get edges composed. You get, and that can, there's a combinatorial explosion problem there that could happen, so it's all lazy. It needs to be lazy. So right now, I think I'm returning a list, which is not lazy. So, oh, no, that's right. I know why I returned a list. When you ask for the edges, you give it what's the maximum number to get. And that's why I return a list. But it is lazy when we compute it. So I can say 10 of them or 100 or whatever, 10. It won't give me more than that. That's why it's a list. So let's see if I can demo that. How about this one? This one I added I did actually get it to shrink to 3 because, and just to show you that it will shrink, I added this bit, which is really, this is really contrived now. It has to be less than 1,000 and not equal to 3. So now 3 will cause it to fail, which means when you shrink and you try 3, it will say, oh, that's prettier than this big number, right? So anyway, that's shrinking. And again, that's just cosmetic. It's not that important, but it's nice that it doesn't blow up. So the other thing that we did in 3.1 is add AnyVals to Scalactic. There's several out there now, but now there's like 10 times more. There's a whole bunch more. And these are Scala AnyVals, which usually don't box, but box when they need to, box more often than we want. But they usually are just the backing type. So it's non-zero int is usually just an int at runtime, we hope. But this one is promising that it's not 0, so I can say how that works is non-zero int 42. Well, that's non-zero, so I get 1. And at runtime, that's probably an int, so I can do that. But if I say 0 at compile time, I get an error. So there's a macro that checks it at compile time for that it's valid. So all of these have these same things. And then there's widening conversions between these and between the regular primitive types and stuff. So if I want, oh wait, before I get to the widening conversions, I'll say val x equals 42, val y equals 0. So if I cannot prove at compile time, because those are literals, I could tell at compile time that it was valid. But if I can't prove it at compile time, then I say non-zero int. You'll get an error at compile time saying, sorry, you're going to have to use a different factory method than apply. So you can use from, and you'll get an option. So if I say from x, that actually was valid, so I got a sum. If I say from y, I got a none. There is a way in 3.1 to say ensuring valid. And actually, this is a assertion. Remember, assuring is an assertion. But this assertion changes the type. So what you just, if you have nearby evidence that something's true, you say ensuring valid, it puts that knowledge into the type, and now you don't have to worry, don't have to remember that that int is non-zero. You actually have it in the type. And there turns out there was a lot of, like, so my nearby evidence that x is going to be a valid non-zero int is up here. I see not too far above in the code that I set it to 42. So if you ever accidentally do this, then you get an assertion error because it's an assertion. Essentially, it's an assertion that once it's done, that's now in the type. And so then what I was going to say is there are widening conversions. So if you need an int and you have a non-zero int, so let's say number res 32. Res 32 is 42. So I can take that 42, that non-zero int, and widen it to an int, and it just widens. There's an implicit conversion, because that's always safe, right? It'll never be a zero int, but it's safe. And you can even go the other way if it's a literal. So if I have like a 42, that's actually an int, right? That's type int. So I say res 4. Oh, this is perfect. Res 42. You don't know how much I had to practice this talk to get that to work. And just say non-zero int. Now that's a narrowing conversion. That may not succeed, right? But because it's a macro, whoops. Oh, of course. See, I actually just helped myself because res 42 is not a literal, so it can't prove at compile time that it's valid, even though it has 42 in the name. But if it actually is a 42, and it can prove at compile time that that is a valid narrowing conversion, it'll do it. And that's kind of like if you say val b colon val by colon byte equals 42, that will work because it, 42 will fit in a byte, right? It'll also fit in a non-zero int, so it's the same kind of thing. So what I did is that's kind of the language of the generators. Because if you have a function that takes an int, but you only want to pass it positive ints, you can just say for all pos ints. And that will be positive ints, but when you pass the pos int to something that takes an int, it just widens it to int. So there are, this is the randomizer, but the generators are in common generators right here. You get these in scope when you mix in property checks. So you get, for example, pos int. So here's pos int. It's actually a generator of pos int, but you can use it for ints if you want to test with ints. But there's also one called pos int values that actually comes back as values. That actually is a generative int that's always positive too, if you just that's what you want, right? So there's tons of these generators based on these AnyVals, and so kind of a social experiment is to what extent will people use and how will they use AnyVals? But I think one use case for them that's pretty strong is property-based testing, and ScalaTest is to use those guys. Because you just say what you want a lot of times, and it's already there. There's also, yeah.
How easy is it to user define these things?
It's not. Essentially, I had to take, for plus, minus, times, divide, I had to actually put that on those AnyVals. What would be nice is an export, like the int that you pass in. They've talked about that in the past, where you can, instead of import, it's the dual. You export things from, the int that is behind the non-zero int. There's an int there backing it. Export its members, and now they're the members of non-zero int with one line of code. What I had to do was write all of them. So it's a lot of work. Doable, but it seems like the language should make that easier. So maybe someday we'll have exports. But there's tuple generators, function generators, and then there's a bunch of between generators, so non-zero ints between two non-zero ints, right? And whatnot. So there's lots and lots of these guys. Okay, so Any questions, other questions so far before I go to function generator? Isn't too much different. This was also something that ScalaCheck, that was one of the things we wanted to try to solve. The only functions that were being generated in ScalaCheck was originally constant functions, but they did add cogen to ScalaCheck. I don't know if those of you have seen what that is. That's for generating interesting functions. But what I used hash code. So it was, because it's there, this isn't Haskell, we have hash code. It was, I thought, simpler for people. And the other thing I try to do in ScalaTest is make pretty error messages. So if you have a function, like basically this function, I'm saying for all functions from int to long, if you map a list of ints, the size will be, well, it's not going to be 4, so I get it to fail, right? Just to show you that the toString of the function actually shows something that you can copy and paste. Let's just say that's it. That's just from the error message. Let me get that space there. That's pretty. Then I can say f of 42, and that's actually what it's always, this was always going to give the same result when you pass the same thing. But if I run the test again, then it would be different next time. So this function, it's basically basing the output on the hash code of the input, because I always have that. Where is it? Right here. So this function is slightly different because this is different. That's the extra bit that's going to be different each time. G equals. So G and F are going to return different values. Val. So say F of 42 was this one. G of 42 is that one. So that's function generation. So ScalaCheck does this now, but it uses something called cogen, which I think is a little too, it's a bit of unnecessary category theory. But then this last one is async properties. ScalaTest has async tests. So I have a demo of that right here. What an async test is, let me just run this thing. Async fun suite. Async property spec, that's what it's called. It is test only star async properties spec. Is that what I called it? I was trying to, I needed to like async property spec factory bean. Okay, so that passed. But what this guy is doing that's a little weird is add soon takes 0 to many ints and returns a future that adds them, but also prints out what they were. Oh, so did I get them? Looks like it was 1 and 2. Right? That's because I hard-coded 1 and 2 in my test right here. So when I run it next time, it's going to be that again. So the way an async test works is this guy returns a future. So if you have a future in hand, I have a future in hand called future sum, I can map an assertion onto it and return a future assertion back to ScalaTest instead of blocking in my test. So it's kind of like play. You get a future, something, maybe future database result or something, and you map it and get a future response that you pass back to play. And it puts that on the shelf and asks to be notified when it completes. And when it completes, it sends a response to the client. What ScalaTest does when it's given a future assertion is it puts on the shelf, asks to be notified when it's complete. And when it completes, it tells the reporter, hey, this test failed or this test succeeded. Yes?
Is that true today?
That's true today, yeah. So this is nothing new. Oh, yeah, sorry.
Yeah. Should have read the docs now.
Yeah, so that's async. And that's, let's see. So I'm going to code comment with block comment. And then I'll just undo the property-based one. So one thing that people have wanted for a long time is to be able to do a for all in an async test and have that work. And have the property return, if the property returns a future assertion. So what this one does, oh, it's really tiny, is it says for all lists of int, when I call add soon and I pass it in, that little underscore star means bust out the elements of the list and pass them in as var args to add-ins. It will add them all up and give me, well, not yet, it will give me a future of that, right, a future sum, essentially. Then I map onto that future sum the same thing, same kind of thing, that it equals the sum of the elements of the list I passed, that I started with, right? But the result of that is a future assertion, and that means your property is a future assertion. So now in 3.1, that means this is a future the for all gives you back a future assertion, which goes right back to ScalaTest, and so it does work. But what you'll see is that you'll get more things printed out. You can see I tried a lot more interesting things to add up here. Yeah, I tried 10 different ways.
Does it wait for the test to get over? Or?
No, it does not. Basically, the test the test body returns like this, but there's a future that until that completes, it won't.
But if you were to put a sleep, let's say, in the function, would it wait or would it exit the test?
If I put a sleep here, then it's inside the future, right?
No, the main one.
The main one, yeah. Yeah, same like if I put a sleep here, let's info it out, but let's put a sleep here. Thread death, jeez. Let's sleep for a second each time, maybe? You could see that, and it doesn't make you wait till too long. Let's see what this looks like. Should just take forever. No, I shouldn't. It's compiling. Okay, once it compiles, oh, this is like thread asleep. Oh, come on. There we go. Well, now wait a second. Oh, that's SBT. Hang on a second. Let's see if I can figure out how to show this. What SBT does is it holds on to it until it's all there, which frustrated me because we do that and we can't get around their feature. There's a way to turn it off. But anyway, you would see it spit out 1 second at a time.
Yeah.
That's what you would see, if you believe me. So anyway, that's async, and that's something people have been wanting for a long time. Any questions about async? Before I go to the very, very last one. This one I'm just going to like use hand wavy thumb. So going back to that original thing, this guy, if I can find it. Well, I've lost it. Maybe I closed it. But anyway, that statement of logic. There has been something that I don't know that will ever go out the door called the expectations, which is a kind of assertion that has a result, doesn't throw an exception. And what this is basically it allows you to make logical statements in your test, essentially. So that's just like not going to be in 3.1, may never be in ScalaTest, I don't know, but that was another thing that, I mean, what I'm sort of feeling like is that, you know, this thing that I showed you here, you know, is really fundamental, and I kind of want to say that functionally. So anyway, that's all I got. I have 2 quick announcements. So basically, one thing is we're doing these open public trainings called Scala Retreats, which is you learn about Scala in a beautiful place. And that, believe it or not, is the East Bay. It's not far from here. So we're having Fundamentals and Advanced in March over there and Effective Scala down in Southern California. So if you're interested in that, you can go to artima.com/training. We are hiring too. We do consulting, so we're available if you need help with Scala. And then I'm a community rep on the advisory board of the Scala Center, and so I'm supposed to represent you to the Scala Center, which is sort of the open source, the nonprofit foundation that guides Scala, and people don't usually complain. So I started doing brown bag lunches for people, and I'm happy to come into your company and do a brown bag lunch for you. And basically, I'm kind of like a psychiatrist. I ask you questions, and you lay on the couch, well, the group, and then I find out I show what's coming in Scala and try to figure out what people like, what they don't like, what they're worried about. So that's listening, and that's all I got. So any other questions? Thank you. Yes.
So how do the generators and auto shrinking work with container types?
Probably make them shorter. So our shrinkers, that was one of the things that I realized we didn't fill in all. We filled in shrinkers for like int, long, float, double, but we didn't fill it in for non-zero int, so I actually wrote that one yesterday. So we haven't, like I said, we're not finished. So shrinking is one of the things I need to refresh my memory what we did and see if there's some way we can do more interesting shrinking out of composed generators. I don't know if we can or not. And like I said, it's kind of just for prettiness. It's not that important. If you know, it's better that it just doesn't blow up. So.
I was just curious because when I saw auto shrinking, it made me think of there's the Hedgehog, the property testing library that also does sort of automatic shrinking, but I believe the way that they do it for containers is that they sort of build up the size of containers and retain all the cases that they've generated. So they don't actually have to shrink anything. They just sort of have the last test case that failed.
Oh, okay.
That's the same
Well, well, one thing that I forgot to mention is we go in the other direction. So ScalaCheck goes from big to small. We go from small to big, and we'll say, you know, like because when you compose these things, there could be huge combinatorial explosions of them. So that's done lazily, but then we just try 100 or whatever we decide to try, right? So, but I'll just try it. Let's say a list of 1, 2, 3. Oh, list dot range 1 to 100. And then what's the other thing we say here to get it to go? Print. Oh, that's kind of hard to read. Let me put a space between it. Print? Can I say for each print line? I'm just seeing what ScalaCheck does and how he gets rid of it, but he's changing this 12 to a negative 12. That's prettier. This is ScalaCheck, so I don't know. Actually, I don't know, but that doesn't look right. I would think you would want to shorten them. I would start with an empty list because we start small. But any other questions? Yes.
Can you change the underlying random number generator?
Well, we wrote one for ScalaTest, so that's.
My concern is that if you have like the vast majority of random number generators, if you try to generate tuple events, they're usually while each integer may be uniformly distributed, the tuple won't necessarily be unless you have a very, very good random number generator.
Well, tuples, tuple twos. Do I say int? I don't know how I say that. This is my own thing. I don't know. Let's say samples 20. So does that look distributed? I don't know. Yeah, we need to test it. So yeah, there's actually some classification stuff in here too that I didn't show you, but ScalaCheck has that as well. So does QuickCheck. Basically, QuickCheck was the founding father of all these things, and there are other property-based testing frameworks in the Scala ecosystem too. They're just ScalaCheck because again, first mover advantage. People mostly use that. So yes.
So I remember that the art generators for product types, tuples, and options. So I say it's a little bit blurry whether it's ScalaCheck or ScalaTest.
No, it's ScalaCheck. Yeah.
Okay, but then I had some APIs where binders and some tries showed up. And I remember that I had to write my own generators for that.
Oh, okay.
It wasn't too difficult, but I was wondering how much work it would be, whether it's worth to add some default generators for some types.
Oh, I think, well, for, yeah, I don't know. I don't have options in either's. So if that's not there, which looks like it isn't there, we will add that. So that's, again, I was like discovering things that aren't there that I thought were there 2 years ago. But anyway, the other one I didn't show is, I forgot that you asked about case classes. Normally, what you like the full-blown one is to do 4 expressions. The way I did that person one, I had to know ints and, I had to know the names of those things. So if you don't want to know the name, so I could say case class, I don't know, dinner has a meal, like a, I don't know, drink and colon string and a utensil, a cost, colon int, double, these days. So if I can say val dinner gen, I haven't had my dinner yet, so I don't know if that's why I'm thinking about this. I can just say instances of dinner. Now that's all I wanted to say, but I can't because I don't have I need an apply and an unapply that gives me back not an option but a thing. And it turns out case classes actually have an unapply method that returns an option that's always a sum, just like I have faith that ScalaCheck's int generator always returns a sum. So I could have used it, but it may not be right. So I said you have to actually write a function that takes a dinner and gives you back the string d.drink, the string, and d.cost, the double, not in an option. I forgot there's an S here I missed. Instances of dinner. See if that worked. So now that's another way to do it. Now I didn't have to say the implicit. It picked up the implicit generator of double and string. So if I say dinner gen, so there is one for that we have, but it's unfortunate that this, maybe in Scala 3 I'll be able to get rid of that because that's kind of ugly. Dinner gen.samples. Let's get 10 dinners. Oh, that looks tasty. Especially this, I love that. Which is, I don't know what that is, but yeah. It's very, I like this price for dinner. This -7 times e to the -6. So. But not, actually I don't like it because it's negative. They don't owe me much, yes.
Could we possibly use the from and to like have a range of values?
Yeah, so that was the, let's see if I can remember what it is. That's a great idea. So here I cannot with instances of, but you can do that in a for. Valgen equals for, and there was a cost in. So I'll say, what's the minimum cost? I'll say doubles between, I don't know, $1 and $100 or something. I think that'll work. We'll see. Oops. It doesn't like that. I lost my whole context here. Okay, and then I need a name. Not a name. What was the other one?
Drink.
Thank you. Drink in, let's say alpha. Alpha, what's it called? Oh, fill it in for me. Well, I'll just say strings, whatever. Strings, because I think it's alpha strings, but I don't want to screw it up. Yield, and I'll say dinner. Drink was first, cost was second, and now we should get something between 110 dot for each print line. We'll print it out like this so you can see it better, but the names are, the drink names are really long. Oh, there's a 267, right? Oh, no, this isn't right. What did I do? 1.0 and 100. This is 33. Oh yeah, that's between 1 and 100. It's just got a huge number of decimal places. So that's how you do that, ranges. Yes?
Can you specify your own edge cases, for example?
Yes.
Times or location?
Yeah, so one of the things that I don't think I've added yet is both shrinking and, so let me show you the API. It's just, you would have to make, you can always make a subclass of generator that there's a method on it that you would implement, but I don't want you to have to do that. I want you to be able to like use a for expression to get a generator and then say dot with edges, and I don't think I've done that yet, but with edges and then you put them in. And then with shrinker and then you put in a function or something, which we haven't done that yet, but I'd like that to be real simple. But right now you could with this, which isn't released, by making a subclass, but yeah. So anybody else?
What's the relationship between ScalaTest and ScalaCheck going forward?
ScalaCheck is the same integration. There's tons of code out there using ScalaCheck. So all we're going to do is just with all these dependencies of external libraries is we'll rename them to org.scalatestplus.ScalaCheck, but and then we'll give you a Scala fix tool to rewrite your code to when we release when we release that. Actually, the ScalaCheck one we're going to change in 3.0.6 just to get it out there. And then some subsequent release down the road will make that a module such that you have to add it to your build, but it's the same exact code. So yeah, that won't change other than the name and that it's an external module. Okay, we should probably quit. It's well past 8, and people are thinking about dinner. Dinner between $1 and $100. Okay, thank you.